How's it going, everybody out there? In this video I'm going to be talking about section 10.2, arithmetic sequences. So in 10.1 you learned about sequences in series and that you do something to get to the next term, and the thing that you do to the next term is always common. You have some rule in order to get to the next term in your sequence. For arithmetic sequences, there is a specific rule, and we are adding or subtracting the common difference. The common difference is called D, to get subsequent terms, so to get the next terms. We have something called an explicit formula, where you have a sub n is dn plus c. We also have a recursive formula, which we explored a little bit in 10.1, where I'm taking the previous term and adding my common difference to it. So exactly what the definition says, add or subtract common difference to get subsequent terms. So I'm taking my previous term, adding the common difference to get the next term. Cool, so an arithmetic sequence would be something like 3, 5, 7, 9, so forth, so on. So pretty much, notice that this is going up by 2 each time. It is adding 2. So we would consider our common difference in this one to be 2. And if you wanted to write a rule, the rule for this one would be 2n plus 1, such that if I substitute 1 to find my a sub 1 term, I have 2 times 1 is 2, plus 1 gets me the 3 term value. For your recursive one, a sub n would be a sub n minus 1 plus 2. Those would be your explicit and recursive formulas. So we're going to actually take it a little bit slower. I know I just gave you pretty much all the information you're going to need for the next, 2 examples, but we're going to look at some more examples, see how we come up with these things using algebra and using our brains, and we're going to love it because we love math. Oh yeah! Alright, take a second, pause the video, write down the example. So in this one, we are determining the common difference and finding the next 4 terms. So if it's saying common difference, I know that this is a arithmetic sequence. So and it looks like this one, it is going up by 7, so my common difference would just be 7. To find the next 4 terms after 32, I would have plus 7 from there, so 39, 46, 53, and 60. Awesome. For this one, it looks like it is going down 8. So my difference would be negative 8. If I continue the pattern, I would have negative 36, negative 44, negative 52, and negative 60. Oh, I'm writing off the page. There we go. Oh, it's so pretty. Thanks. You guys are so sweet. Oh, I love you too. Okay, and in part C, if I'm looking for the common difference, well, it looks like this is in the form dn plus c, where my c is negative 6, my difference is 3, so my common difference is 3 here. To find the next 4 terms, well, I can just substitute in 1 to find my first term. So I'd have a sub 1 is 3 times 1 minus 6, which would be, what, negative 3? And then I would do the same thing for a sub 2, and I would get its negative 6. No, it's not. It is 0. And then a sub 3 would be 3. A sub 4 would be 6. And there would be my first 4 terms. Sweet. All right, for these 2 examples, it says find an explicit and recursive formula for the sequence. So our explicit formula is at least dn plus c. Our recursive is at least a sub n equals a sub n minus 1 plus the difference. So in both of these, I need to know the difference. So it looks like in this one, my difference would be 4. So far in my explicit formula, I know that a sub n is equal to 4n plus some number. So now here's the thing. It gives me my first term is 18. So if I substitute in, when my first term is 18, 4 times 1 plus c, that will help me solve for c. Because now if I just subtract that 4 to the other side, I have 14 is c, and I can rewrite my explicit formula as a sub n is 4n plus 14. Yay! And then for the recursive one, I have a sub n is a sub n minus 1 plus the difference, which is 4, so plus 4. There's my recursive. There is my explicit. Okay, in this next one, it looks like my difference is negative 4. So in my equation, I know I have negative 4n plus c. So here's the way that I'm going to do it. I know my first term is 12. So if I substitute in 1 for n, right now I have negative 4 times 1, which is negative 4. I know my first term is supposed to be 12, so I have to decide what number I have to add to negative 4 such that I will get 12. Well, that number would be 16. So I know my rule should be negative 4n plus 16. Either way you want to do that, if you want to just think about it, cool. If you want to do the algebra, you may be right more often than not. But if you are fine about just thinking about it, cool, you guys can do that. So there's your formula. And to get the recursive, you have a sub n minus 1 minus your difference, which is minus 4. Oh, happy day! All right, if we have a sum of numbers, and we want to, or sorry, not a sum, a sequence of numbers, and we want to find the sum of that sequence, as long as this is an arithmetic sequence, so what I mean when I say as long as it's an arithmetic, if it follows the rule dn plus c, if you could find a formula like that, then you can use this formula. This n is the number of terms you have, so number of terms. The a sub 1 is obviously the first term. A sub n will be your last term value. Cool, so let's explore with this formula and now we can use it. So for example, we have something like this. With this, it is in the form dn plus c, because there is my dn plus c. So this just means my difference is negative 6. So if I have the terms from 1 to 12, for my formula, n over 2, a sub 1 plus a sub n, the n there is 12 because I have 12 terms. So I have 12 divided by 2 times my first term plus my last term. Well, in order to find your first term, you can just substitute in 1 into your formula. So a sub 1 is 2 minus 6 times 1, which is negative 4. So I have negative 4 right there. Then I need my last term. So I need a sub 12. So 2 minus 6 times 12 should be negative 72. So negative 70. So that will be negative 70. Now it's just a matter of making sure that I plug this in my calculator correctly. So I have, what is that, 6 times 74, math. Haha, math. Okay, so you should get something like that. Yay. Let's look at another. Okay, looking at this one. Make sure that you guys pay attention to what term you are starting on and how many terms you actually have. So in this last one, notice we had 12 terms and we counted from 1 to 12, right? So you have, well, this is going to be hard. Usually I show you on my fingers. 1, 2, 3, 4, 5. Okay, use your fingers, count to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? You end with a 2. So that means that you have 12 numbers. Haha, scissors. So you have 12 terms involved. Yay. So with this one, if you start counting at 4, that means 4 is your 1. So you have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Notice you have a full hand. Full hand. Yay, full hand. So that means I have 15 terms. Okay, well, if I do 18 minus 4, that would give me 14, but I know I have 15 terms, so I have to add back the 1 to tell me that n is 15. Notice, if you do the same sort of logic on this last one, if you do 12 minus 1 equals 11, but I know I have to add back the 1 because I know that n is 12. So basically, all that is saying is that when you are starting counting, you can find the difference of the numbers, but you have to include the number that you started counting on. So the difference between 18 and 4 is 14, but to include the number that you started counting on, add 1 back to it. So you have 15 terms altogether here. So you have 15 divided by 2 times your first term plus your last term. Here my first term, notice you started us on 4. So a sub 4 is 12 plus 2 times 4. So we should have 20. 20 times 18. Oh, 36 plus 12 is 48. So 48. No. So now it's just a matter of plugging in everything correctly. So we have 68, 34 times 15. Math says 510. Yay. Next example. Write each series in sigma notation. So don't forget, sigma notation is just the summation notation. It says the lower bound is given. So all that means is that the number down here is given. That is n equals 1. So your first term is 1. What that also tells us is our first term is 8. So that will help us write our rule, because we know we have to have the rule inside of the sigma, and we have to have our last term on top. So in order to write our rule, it looks like the difference is 4. So a sub n equals 4n. If I substitute 1, it's 4, but it needs to be 8, so I'm going to put plus 4. So far I have n equals 1 of 4n plus 4. Now to figure out how many terms I have involved, it gives me that the last term is 60, and I know that's a sub n. So in order to find what this n right there is, I know 60 is my last term, so I have 4n plus 4. If I subtract 4, I have 56 equals 4n. 56 divided by 4, 28, 14, n is 14. So there is your top term. Hey, sigma notation. Well, let's do another one of those. Okay, I didn't write the instructions again because it's part B, that was part A, same instructions, right in sigma notation, the lower bound is given. Oh, where'd it go? There it is. So I have my lower bound, so I can say n equals 2, and what that tells me also is that my second term is negative 1. So when I write my rule, a sub n equals, it looks like it's going up by 1, so I have n plus c. I know my second term is negative 1. That's kind of close. It took me a little bit. I'm sorry. So you have negative 1 when you plug in 2 plus c. So that tells me that c is negative 3. So my rule then should be n minus 3. To figure out my last term value, I can say n minus 3 equals 7. Add the 3 over, n is 10. So there are 10 terms there. Yay, sigma notation. Oop, wrote through the 2. You understand? I understand. Whoa. Alright, and in this one, we are given a couple of terms and it's asking us to find the common difference. Well, notice it gives us the fourth term, 20th. We don't have the 5th, we don't have the 6th, or the 7th, or the 8th, or the 9th, but I have the 10th is 84. And if it adds the same number, I have plus the difference, 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 right? So I'm adding the difference 1, 2, 3, 4, 5, 6 times I'm adding the difference. So I know 6 times the difference is the difference altogether, which would be 64. So I have 6 times the difference is 64. Now it's really easy to solve for the difference. Just divide by 6 and divide by 6, and you'll have the difference is, what is that, 10 and 2/3, 10 and 2/3, or you can say, what is that, 32 over 3? Or you can say 10.6 repeating, or you can say 10.67, or you can say I'm crazy because this is also true. Alright, I'm going to do one more of these. I'm just going to make it up real fast. Top of the head. Oh, look, top of the head. That was a funny joke. I don't care if you didn't like it. I loved it. It was my favorite. 100, 16. What do you guys want to make it? 40? Let's make it 40. Beautiful. So in this one, notice between 12 and 16, we have 4 times the difference. 100 minus 40 is negative 60. It went down 60, so my difference then, if I divide by 4, difference should be negative 15. Yay. Hopefully this video has helped you guys out. As always, please ask me questions. I love you guys. You my boos, my bays, you everything, you even my monkeys. Bye-bye.